The asteroid belt, a vast expanse of space between Mars and Jupiter, is home to millions of rocky bodies, each one a silent witness to the birth of our solar system. Yet, despite its size and significance, only a fraction of these celestial objects have ever been studied. What secrets lie hidden in this cosmic graveyard? Could these ancient rocks hold clues to the origins of life itself, or might they harbor resources that could propel humanity into a new era of exploration and discovery? The asteroid belt is more than just a collection of debris. It's a treasure trove of unanswered questions, each one a mystery waiting to be unraveled. Today, we're diving into 35 of the most fascinating and unexplored enigmas of this region, starting with a mystery that challenges everything we think we know about the early solar system. Get ready, because what you're about to discover might just change how you see the universe forever. The first mystery we're tackling takes us back to the very beginnings of our solar system, a time of chaos, collisions, and cosmic creation. How did the asteroid belt come to be? This question has puzzled scientists for centuries, and even today, there's no single, definitive answer. One leading theory suggests the asteroid belt is all that remains of a shattered planet, torn apart by gravitational forces or a catastrophic collision billions of years ago. Imagine a world, perhaps as large as Mars, obliterated in an instant, its fragments scattering into the void. These shattered remnants, frozen in time, could be the asteroids we see today. But there's another compelling idea. What if the asteroid belt is simply material that never managed to form a planet at all? Picture this, a swirling disk of dust and rock, caught in the gravitational tug of war between Jupiter and the Sun. The intense pull of Jupiter's gravity could have disrupted the process, preventing these pieces from ever coming together. This theory paints the asteroid belt as a snapshot of the solar system's infancy, a region where time stood still, preserving the building blocks of planets in their rawest form. Recent studies have only deepened the mystery. Planetary scientists have discovered that certain types of asteroids, like the carbon-rich ones, are oddly concentrated in specific regions of the belt. Why is that? Some researchers believe it hints at ancient, long-lost processes that shaped the early solar system. Others suggest it could be evidence of migrating planets, whose movements stirred the asteroid belt like a cosmic spoon, sorting its contents in ways we're only beginning to understand. The truth is, we're still piecing together this cosmic puzzle. Every new mission to the asteroid belt, every rock we analyze, brings us closer to understanding, but also raises more questions. What forces truly shaped this region, and what does it tell us about the origins of not just the asteroid belt, but our entire solar system? As we ponder these questions, let's shift our focus to the next mystery: the composition of these ancient rocks. What do they reveal about the building blocks of planets, and perhaps even life itself? The composition of asteroids is far more fascinating and varied than you might expect. These ancient rocks aren't just simple chunks of stone floating in space. They're a patchwork of materials, each one telling a unique story about the early solar system. From metals like iron and nickel to rare organic compounds, asteroids are like time capsules, preserving the ingredients that once swirled in the primordial soup of our cosmic neighborhood. But what exactly are they made of, and what can their composition teach us about the origins of planets, or even life itself? Take carbonaceous asteroids, for example. These dark, carbon-rich bodies are some of the most primitive objects in the solar system. They're packed with organic molecules, the kind that could have played a role in sparking life on Earth. Some even contain water ice, a discovery that stunned scientists and raised intriguing questions. Could asteroids have delivered water to our planet billions of years ago? If so, they might not just be relics of the past, they could be the very reason we're here today. But studying these distant objects isn't easy. Unlike planets or moons, asteroids are small, often irregularly shaped, and incredibly far away. Most of what we know comes from telescopic observations or the rare samples returned to Earth by spacecraft. Missions like OSIRIS-REx, which visited the asteroid Bennu, and Hayabusa 2, which explored Ryugu, have given us unprecedented glimpses into their makeup. Both asteroids turned out to be rubble piles, loose collections of rocks and dust held together by gravity, and both contained surprising amounts of organic material and water-bearing minerals. These findings suggest that asteroids might not just be leftovers from planet formation. They could be reservoirs of the very ingredients needed to create life. Yet, for every answer these missions provide, they also raise new questions. Why do some asteroids seem so rich in water while others are bone dry? How did organic compounds survive in the harsh environment of space for billions of years? And what other secrets might these ancient rocks be hiding? As we continue to study these celestial bodies, one thing is clear: asteroids are far more complex than they appear. Their composition offers a window into the past, revealing clues about how planets formed and how life might have begun. But as we unravel these mysteries, another intriguing question arises. Why do so many asteroids have such bizarre shapes and structures? Let's explore that next. When you think of asteroids, you might picture smooth, round rocks floating through space, but the reality is far stranger. Many of these ancient objects are anything but symmetrical. Some look like lumpy potatoes, others resemble spinning tops, and a few even have small moons orbiting them. These peculiar shapes aren't just quirks of nature. They are clues about the violent, chaotic history of the asteroid belt. So, how do asteroids end up looking so bizarre? The answer lies in a combination of collisions, rotation, and gravity. Asteroids are constantly bumping into each other, and these impacts can shatter them into irregular fragments or reshape them entirely. Over millions of years, these collisions smooth some edges while leaving others jagged, creating the lumpy, misshapen forms we see today. But it's not just impacts that shape these celestial bodies. Rotation plays a huge role, too. As asteroids spin, centrifugal force can stretch them out, turning them into elongated or even dumbbell-like shapes. And in some cases, gravity can pull material toward the equator, giving them a distinctive spinning top appearance. Take the asteroid Ida, for example. This potato-shaped rock, discovered in the 19th century, is one of the most famous asteroids in the belt, and for good reason. When the Galileo spacecraft flew past it in the 1990s, it revealed something extraordinary. Ida has a tiny moon, Dactyl, orbiting it. This discovery was groundbreaking because it showed that even small asteroids can have moons, raising questions about how such systems form. Did Dactyl break off from Ida during a collision? Or was it captured by Ida's gravity? Scientists are still debating the possibilities, but one thing is clear: binary asteroid systems like Ida and Dactyl are far more common than we once thought. Modeling these irregular shapes and predicting their behavior is no easy task. Unlike planets, which are mostly spherical and easier to study, asteroids can be wildly unpredictable. Their odd shapes affect how they spin, how they interact with other objects, and even how they reflect sunlight. This unpredictability makes it challenging for scientists to plan missions or predict their trajectories accurately. Yet, understanding these shapes is crucial not just for science, but for future exploration. If we're ever going to mine asteroids or land on them, we need to know how they'll behave. But the mysteries don't stop at their shapes. Why do some asteroids have moons while others don't? Why do binary systems exist at all? These questions hint at the complex dynamics at play in the asteroid belt, where gravity, collisions, and time itself have sculpted these objects into the strange forms we see today. As we marvel at these oddly shaped rocks, another tantalizing question emerges. What treasures might they hold? Could the asteroid belt be hiding resources that could revolutionize life on Earth or beyond? That's the next mystery we'll explore. Imagine a future where the wealth of nations isn't found deep within the Earth, but floating among the stars. The asteroid belt, often seen as a barren expanse of rock, could one day become the ultimate gold rush, or rather, the ultimate platinum rush. These ancient remnants of the solar system aren't just relics of the past. They're potential treasure chests, packed with rare and valuable resources like platinum, gold, and rare earth metals. But could we really mine asteroids? And what would it take to turn this sci-fi dream into reality? The idea of space mining isn't as far-fetched as it sounds. Asteroids like Psyche, a massive metallic body orbiting between Mars and Jupiter, are believed to contain enough iron, nickel, and precious metals to dwarf Earth's entire supply. Scientists estimate that Psyche alone could be worth quadrillions of dollars, a staggering figure that has sparked the interest of both private companies and governments. But mining an asteroid isn't just about the potential payoff. It's also about overcoming enormous technological and logistical hurdles. For starters, getting to these distant rocks is no small feat. Spacecraft would need to travel millions of miles, navigate the complexities of zero-gravity environments, and find a way to extract resources without destabilizing the asteroid itself. Then there's the challenge of bringing those materials back to Earth, or perhaps even using them in space to build habitats, fuel stations, or spacecraft. The cost of such missions is astronomical, no pun intended, and the technology required is still in its infancy, but the challenges don't stop at engineering. Space mining also raises profound ethical questions. Who owns the resources in the asteroid belt? Is it fair for a single nation or company to profit from what could be considered the common heritage of humanity? And what about the environmental impact? While mining asteroids might reduce the need for destructive practices on Earth, it could also introduce new risks, like altering the orbits of these objects or creating space debris that threatens future missions. Despite these challenges, the race to mine asteroids is already underway. Companies like Planetary Resources and Deep Space Industries have been exploring ways to exploit these celestial resources, while nations like Japan and the United States have launched missions to study asteroids up close. Japan's Hayabusa 2 mission, for example, successfully collected samples from the asteroid Ryugu, proving that it's possible to retrieve material from these distant bodies. As we stand on the brink of this new frontier, one thing is certain: the potential rewards are immense, but so are the risks. Whether space mining becomes a reality or remains a distant dream, it forces us to confront big questions about our place in the universe and our responsibility to protect it. But while we dream of mining asteroids for their riches, there's another, more urgent reason to study them: their potential to threaten life on Earth. What happens when one of these ancient rocks sets its sights on our planet? That's the next mystery we'll explore. The cosmos may seem vast and empty, but it's far from peaceful. Hidden within the asteroid belt are countless rocks, some of which could pose a serious threat to our planet. While most asteroids stay in their stable orbits, there's always the possibility that one could veer off course and head straight for Earth. This isn't just science fiction. It's a real and present danger that scientists are working tirelessly to understand and mitigate. But what makes these ancient rocks so unpredictable, and how do we prepare for the worst-case scenario? Let's start with the obvious. Not all asteroid impacts are created equal. A small meteorite burning up in the atmosphere might create a dazzling light show, but a larger asteroid could cause devastation on a global scale. Take the Chelyabinsk meteor, for example. In 2013, a relatively small asteroid, just about 20 meters across, exploded over Russia with the force of 30 Hiroshima bombs. The blast shattered windows, injured over 1,000 people, and served as a stark reminder of how vulnerable we are to these cosmic visitors. What's even more unsettling is that the Chelyabinsk meteor came without warning. It approached Earth from the direction of the Sun, making it nearly impossible to detect until it was too late. This highlights one of the biggest challenges in tracking asteroids: their unpredictable behavior. Some asteroids, particularly those with irregular shapes or unstable orbits, can change direction unexpectedly. Gravitational interactions with planets, the pressure of sunlight, or even outgassing, where an asteroid releases gas like a comet, can alter their paths in ways that are difficult to predict. This unpredictability is why missions like NAS, a DART double asteroid redirection test, are so crucial. In 2022, DART made history by successfully crashing into the asteroid Dimorphos, altering its orbit around a larger companion asteroid. This groundbreaking experiment proved that we might one day be able to deflect a dangerous asteroid away from Earth. But while DART was a major step forward, it also revealed just how complex these missions are. Deflecting an asteroid requires precise calculations, advanced technology, and a lot of luck. The stakes couldn't be higher. 66 million years ago, an asteroid impact wiped out the dinosaurs and reshaped life on Earth. While such catastrophic events are rare, they're not impossible. That's why scientists are constantly monitoring the skies, cataloging near-Earth objects, and refining their models to predict potential threats. Yet, even with all this effort, there's still so much we don't know. Why do some asteroids suddenly change course? How can we improve our detection systems to spot incoming threats sooner? And what other strategies could we develop to protect our planet? As we grapple with these questions, another intriguing possibility emerges. Could the asteroid belt hold not just dangers, but also the building blocks of life? What if these ancient rocks aren't just threats, they're also potential cradles of life itself? That's the next mystery we'll explore. The idea of life existing on asteroids might sound like something straight out of a science fiction novel, but it's a question that has captivated scientists for decades. Could these ancient rocks, drifting silently through the void, harbor the building blocks of life or even life itself? It's a tantalizing possibility, one that challenges our understanding of where life can exist and how it might spread across the cosmos. At the heart of this mystery lies the concept of panspermia, the idea that life could travel through space, hitching a ride on asteroids, comets, or other celestial bodies. Imagine a scenario billions of years ago. A massive asteroid impact on a distant world sends debris hurtling into space. Among that debris are tiny microbes, encased in protective layers of rock, surviving the harsh conditions of space. Eventually, Some of that debris lands on another planet, seeding it with life. Could Earth itself have been the recipient of such a cosmic delivery? The discovery of organic molecules on asteroids like Ryugu and Bennu has given this theory new weight. These molecules, which include amino acids and other compounds essential for life, suggest that the ingredients for life may be far more widespread in the universe than we once thought. Some scientists believe that asteroids could have delivered these materials to Earth during its early, chaotic years, providing the raw ingredients needed for life to emerge. But the implications go even further. Could asteroids still harbor life today, while the harsh environment of space, with its extreme temperatures and lack of atmosphere, makes it unlikely for complex organisms to survive? Some researchers speculate that hardy microbes, capable of withstanding extreme conditions, might exist deep within these ancient rocks. These microbes, if they exist, could be remnants of life that originated elsewhere, preserved in the icy depths of asteroids for billions of years. Of course, this is still largely speculative. We've yet to find definitive evidence of life on asteroids, but missions like OSIRIS-REx and Hayabusa 2 are bringing us closer to answering these questions. By studying the organic compounds and water-bearing minerals found on these rocks, scientists hope to uncover clues about how life began, not just on Earth, but potentially elsewhere in the solar system. As we ponder the possibility of life on asteroids, another question arises. What role did these ancient rocks play in shaping the solar system itself? Could they hold clues to the dramatic events that defined our cosmic neighborhood billions of years ago? That's the next mystery we'll explore. Asteroids are more than just rocky relics, they're cosmic time capsules, preserving the raw materials of the early solar system in a way that planets, with their active geology and weather, cannot. Think of them as ancient archives, holding secrets from a time when the sun was young and the planets were still forming. But here's the twist: not all asteroids have kept their stories intact. Some remain astonishingly pristine, while others bear the scars of intense heat, collisions, or other transformative events. Why is there such a stark difference, and what can these variations tell us about the chaos of the early solar system? Take carbonaceous chondrites, a type of asteroid that's often described as a window into the past. These dark, carbon-rich rocks are thought to be some of the most primitive objects in the solar system, virtually unchanged since their formation over 4.5 billion years ago. They contain water, organic compounds, and even tiny grains of stardust that predate the sun itself. Studying these asteroids is like flipping through the pages of a cosmic history book, offering clues about the conditions that existed long before Earth was born. But not all asteroids are so well preserved. Some have been dramatically altered by heat, possibly from the decay of radioactive elements or from intense collisions. These heated asteroids, known as chondrites, often have a more metallic or rocky composition, their original features melted away or reshaped. The contrast between pristine and altered asteroids raises fascinating questions. What caused some to remain untouched while others were transformed? Was it their location in the asteroid belt, their size, or simply chance? Missions like OSIRIS-REx and Hayabusa 2 are helping us answer these questions by bringing back samples from asteroids like Bennu and Ryugu. These missions are like interplanetary treasure hunts, carefully selecting targets that could reveal the most about the solar system's origins. The samples collected are already providing groundbreaking insights. For instance, Ryugu's surface turned out to be much drier than expected, challenging previous assumptions about water distribution in the early solar system. Meanwhile, Bennu's rubble pile structure suggests it formed from the debris of a much larger body, hinting at a violent past. The more we learn, the clearer it becomes that asteroids are not uniform. Each one has its own story, shaped by the unique forces it encountered over billions of years. Yet, as we uncover these stories, we're also left with new puzzles to solve. Why do some asteroids seem to have avoided the chaos that reshaped others? And what can their differences teach us about the broader processes that shaped the solar system? As we marvel at these ancient time capsules, another intriguing mystery comes into focus: the strange, often unpredictable orbits of some asteroids. Why do these rocks sometimes follow paths that defy expectations? And what forces are at play in shaping their journeys through space? That's the next mystery we'll explore. The asteroid belt is a cosmic dance floor, with billions of rocky bodies swirling in a complex choreography around the sun. Most asteroids follow predictable paths, moving in the same direction as the planets counterclockwise, if you're looking down from above the solar system. But every now and then, you'll find a rebel. Some asteroids break the rules, carving out bizarre, unpredictable orbits that defy expectations. These cosmic outliers are more than just anomalies. They're windows into the chaotic forces that shape our solar system. Take the asteroid 2015 BZ 509, for example. This strange object orbits the Sun in the opposite direction of nearly everything else, a phenomenon known as retrograde motion. How did it end up going the wrong way? Scientists believe it might have been captured from another star system, flung into our solar system during a close encounter billions of years ago. But that's just one theory. Others suggest it could be the result of a massive collision or gravitational interactions with Jupiter, which has a knack for stirring up trouble in the asteroid belt. Then there are the near-Earth asteroids, those that cross our planet's path. These objects are especially intriguing and concerning because of their potential to collide with Earth. But their orbits are far from straightforward. Some, like the asteroid Bennu, have trajectories that shift slightly over time due to the Yarkovsky effect, a subtle force caused by the uneven heating and cooling of their surfaces. This makes predicting their paths incredibly challenging, even for the most advanced computers. What's truly fascinating is how these bizarre orbits reveal the dynamic nature of the solar system. Gravity, collisions, and even the pressure of sunlight can nudge asteroids onto new paths, creating a cosmic game of billiards that plays out over millions of years. Each unusual orbit tells a story of near misses, close encounters, and the delicate balance of forces that keep our solar system in motion. As we unravel the mysteries of these peculiar orbits, another question arises. Could some of these asteroids be more than just rocks? What if they're hiding something far more extraordinary, something that might hint at the presence of intelligent life? That's the next mystery we'll explore. What if asteroids aren't just ancient rocks or potential sources of precious metals? What if they're hiding something far more extraordinary, something that could rewrite our understanding of life in the universe? This brings us to one of the most speculative, yet utterly captivating mysteries of the asteroid belt. Could these cosmic wanderers contain alien artifacts? The idea isn't as far-fetched as it might seem. Asteroids, with their unchanging surfaces and long, quiet histories, could serve as natural storage units for remnants of extraterrestrial technology, or even life. Imagine a scenario where an advanced civilization, long gone, left behind probes, machinery, or other artifacts that drifted into our solar system and became embedded in these ancient rocks. While this might sound like the plot of a sci-fi blockbuster, some scientists argue it's a possibility worth investigating. The challenge, of course, is proving it. Searching for alien artifacts on asteroids is like trying to find a needle in a haystack, except the haystack is millions of miles away, and the needle might not even exist. Most scientists approach such claims with healthy skepticism, emphasizing the need for rigorous evidence before jumping to conclusions. After all, extraordinary claims require extraordinary proof. But that hasn't stopped researchers from exploring the idea. One intriguing approach involves looking for anomalies, unusual features, or materials that don't fit with what we know about asteroids. For example, could an asteroid with an unusually high concentration of rare metals or an odd shape be a sign of artificial origin? Or what if we found something as simple as a metallic structure or a manufactured object embedded in the rock? These are the kinds of discoveries that would demand serious investigation. Missions like OSIRIS-REx and Hayabusa 2 are already collecting samples from asteroids, giving scientists unprecedented access to these ancient rocks. While their primary goal is to study the origins of the solar system, they're also opening the door to answering bigger questions. Could these missions inadvertently stumble upon something that hints at intelligent life? It's unlikely, but not impossible. The implications of such a discovery would be profound. Finding evidence of alien technology, even in the form of ancient artifacts, would change how we see ourselves in the universe. It would suggest that we're not alone, and that life or intelligence might be far more common than we think. But until such evidence is found, the idea remains a tantalizing possibility, one that challenges us to keep pushing the boundaries of exploration and imagination. As we ponder the possibility of alien artifacts hidden among the asteroids, another question arises. What role did these ancient rocks play in the formation of planets? How did they shape the solar system we know today? That's the next mystery we'll explore. Asteroids are often called the building blocks of planets, and for good reason. These ancient rocks hold clues to how our solar system came to be, offering a glimpse into the chaotic processes that shaped worlds like Earth. But how exactly did asteroids contribute to planetary formation, and why do some of them seem so different from others, with some packed with water and organic molecules, while others are dry and metallic? These questions take us to the heart of one of the asteroid belt's greatest mysteries. Billions of years ago, the solar system was a swirling cloud of dust and gas, slowly coalescing into planets. Asteroids, it turns out, played a crucial role in this process. As the early planets grew, they swept up smaller objects in their paths, including asteroids. Some of these asteroids carried water and organic compounds, delivering them to the young Earth and other planets. This theory, known as the late Veneer hypothesis, suggests that asteroids might have been the cosmic couriers that brought the ingredients for life to our planet. But not all asteroids are the same. The asteroid belt is a patchwork of different types, each with its own unique composition. Carbonaceous asteroids, for example, are rich in water and organic molecules, making them potential sources of the building blocks of life. On the other hand, metallic asteroids like Psyche are composed primarily of iron and nickel, remnants of the cores of ancient protoplanets that were shattered in violent collisions. This diversity raises an intriguing question. Why did some asteroids retain water and organic material, while others lost them or never had them to begin with? The answer likely lies in their histories. Some asteroids formed farther from the Sun, in the colder regions of the early solar system, where water and other volatiles could condense and remain frozen. Others, like those closer to the Sun, might have been heated to the point where water and organic compounds evaporated, leaving behind dry, metallic remnants. Collisions also played a key role. When asteroids crashed into each other, the heat and pressure could have stripped away water and organic material, altering their composition forever. These collisions weren't just destructive, they were also creative. The debris from asteroid impacts likely contributed to the formation of moons, rings, and even new asteroids. This chaotic process of destruction and rebirth shaped the asteroid belt into what we see today, a mix of pristine, water-rich rocks and dry, metallic fragments, each one a testament to the dynamic history of our solar system. As we unravel the mysteries of planetary formation, another tantalizing possibility emerges. Could asteroids one day become more than just relics of the past? What if they became the foundation for humanity's future in space? That brings us to our next mystery, the potential for asteroid colonies and how these ancient rocks might serve as stepping stones for exploring the cosmos. Imagine a future where humanity doesn't just visit space, we live there. What if, instead of building colonies on distant planets, we set up shop on asteroids? It's a concept that sounds like something straight out of science fiction, but the idea of asteroid colonies is gaining serious attention from scientists and space agencies alike. These ancient rocks, once seen as little more than cosmic debris, could one day become the foundation for humanity's expansion into the solar system. But what would it take to make this vision a reality? Living on an asteroid presents a unique set of challenges. For starters, there's the issue of gravity, or rather, the lack of it. Most asteroids have such weak gravity that even a small jump could send you flying off into space. Creating a stable habitat would require some ingenious engineering, like spinning structures to simulate gravity or anchoring living quarters deep within the asteroid itself. Then there's the problem of radiation. Without the protection of Earth's atmosphere and magnetic field, colonists would be exposed to harmful cosmic rays and solar radiation. Shielding would be essential, whether through thick layers of rock or advanced materials designed to block these dangers. But despite these hurdles, the potential benefits are enormous. Asteroids are rich in resources, from metals like iron and nickel to water ice that could be used for drinking, growing food, or even producing rocket fuel. Setting up colonies on these rocks could provide a ready supply of materials for further exploration, turning asteroids into cosmic gas stations and construction sites. They could also serve as stepping stones for missions to Mars and beyond, offering a waypoint where spacecraft could refuel and resupply without needing to return to Earth. The idea isn't just theoretical. Some space agencies and private companies are already exploring ways to make asteroid colonies a reality. NASA Artemis program, for example, aims to establish a sustainable presence on the Moon, which could serve as a testing ground for technologies needed to live on asteroids. Meanwhile, companies like SpaceX are developing the heavy lift rockets that could transport equipment and supplies to these distant locations. As we dream of a future where humans live among the stars, another intriguing question emerges. What secrets do asteroids hold that we haven't even considered? For instance, why do some asteroids have magnetic fields, a feature usually associated with planets? This strange phenomenon hints at even deeper mysteries waiting to be uncovered. The potential for asteroid colonies is more than just a futuristic fantasy. It's a glimpse into what could be the next chapter of human exploration. But as we look toward the stars, we must also confront the challenges and unknowns that come with such ambitious dreams. And with that in mind, let's turn our attention to the next mystery, the strange magnetic fields of some asteroids, a phenomenon that could rewrite our understanding of these ancient rocks. When we think of magnetic fields, planets like Earth or Jupiter usually come to mind, but here's something that might surprise you. Some asteroids have magnetic fields too. This discovery has left scientists scratching their heads. How can these small, seemingly inert rocks generate magnetic fields, and what do these fields tell us about what's happening deep inside them? Let's dive into this magnetic mystery and uncover what it could mean for our understanding of these ancient bodies. Take the asteroid Vesta, for example. This massive rock, one of the largest in the asteroid belt, has a weak but detectable magnetic field. Scientists believe this magnetism is a relic of its past, possibly dating back to a time when Vesta was molten and its core generated a magnetic field through a dynamo effect similar to how Earth's magnetic field is produced. But here's the twist. Vesta is now solid and cold, so how did this magnetic field persist? One theory suggests that as Vesta cooled, its magnetic signature became frozen into its surface rocks, preserving a snapshot of its ancient magnetic activity. This raises even more questions. Could other asteroids, especially those with metallic cores, also have magnetic fields? And if so, what does that tell us about their formation and evolution? Some researchers speculate that magnetic fields might be more common in the asteroid belt than we realize, particularly among asteroids that were once part of larger protoplanets with molten interiors. These magnetic remnants could be like cosmic fingerprints, offering clues about the violent collisions and transformations that shaped the early solar system. But the mystery doesn't end there. How do these fields form in the first place? Some asteroids, like Vesta, might owe their magnetism to their metallic cores, while others could have acquired it through impacts or interactions with the solar wind. There's even the possibility that certain asteroids contain magnetic minerals that align in response to external forces, creating localized magnetic anomalies. As we unravel these questions, one thing becomes clear: magnetic fields are more than just a curiosity, they are a window into the hidden lives of asteroids. By studying them, we can learn about the internal structures, histories, and even the physical processes that have shaped these ancient rocks over billions of years. But while magnetic fields offer fascinating insights, they're just one piece of the puzzle. What about the atmospheres of asteroids? Could these seemingly barren rocks have thin, temporary atmospheres of their own? That's the next mystery we'll explore. When you picture an asteroid, you probably imagine a barren, airless rock drifting silently through the void of space. But here's something that might surprise you. Some asteroids actually have atmospheres. Not the thick, life-sustaining kind we're used to on Earth, but incredibly thin, temporary envelopes of gas that cling to their surfaces. How is this possible? And what can these ghostly atmospheres tell us about the nature of these ancient rocks? The key to understanding these tenuous atmospheres lies in a process called outgassing. When certain asteroids are exposed to the heat of the sun, volatile compounds like water ice or frozen carbon dioxide, trapped beneath their surfaces, can sublimate, turning directly from a solid into a gas. This gas escapes into space, creating a faint, temporary atmosphere that might last only hours, days, or weeks before dissipating. It's a fleeting phenomenon, but one that offers fascinating insights into the composition and history of these celestial bodies. Take the asteroid Ceres, for example. This dwarf planet, the largest object in the asteroid belt, has been observed releasing plumes of water vapor from its surface. These plumes suggest that Ceres harbors subsurface ice, which occasionally vents into space, creating a thin, transient atmosphere. Similar outgassing has been detected on smaller asteroids, like Bennu, which was found to be ejecting tiny particles of dust and gas during its close encounters with the Sun. These discoveries challenge our assumptions about asteroids being completely dry and lifeless, hinting at a more dynamic and complex reality. Studying these wispy atmospheres, however, is no easy task. Because they're so thin and short-lived, they're incredibly difficult to detect. Scientists rely on advanced telescopes and spacecraft equipped with sensitive instruments to capture even the faintest traces of gas or dust. Even then, the data is often ambiguous, requiring careful analysis to distinguish an asteroid's atmosphere from other phenomena, like solar-wind interactions or surface activity. These challenges haven't stopped researchers from trying. By studying these fleeting atmospheres, scientists hope to learn more about the volatile compounds hidden within asteroids' compounds that could hold clues to the early solar system's composition and the origins of water on Earth. But as we uncover these secrets, another intriguing possibility emerges. Could these thin atmospheres play a role in the search for extraterrestrial intelligence? Imagine an asteroid with a faint, temporary atmosphere acting as a beacon, signaling the presence of volatile compounds, or perhaps even something more. Could advanced civilizations use outgassing as a way to mark their presence in the cosmos? It's a speculative idea, but one that ties into the broader question of how asteroids might fit into humanity's quest to find life beyond Earth. As we ponder the mysteries of these ghostly atmospheres, another question arises. What role do asteroids play in the search for extraterrestrial intelligence? Could these ancient rocks hold clues to the existence of other civilizations in the universe? That's the next mystery we'll explore. The search for extraterrestrial intelligence has taken us to the farthest reaches of the cosmos, from distant stars to the icy moons of our own solar system. But what if the key to finding alien civilizations isn't out there among the stars? It's right here, hidden among the asteroids. This idea might sound like something from a science fiction novel, but it's a possibility that some scientists are taking seriously. Could these ancient rocks, drifting silently through space, hold clues to the existence of intelligent life beyond Earth? One intriguing theory suggests that advanced civilizations might use asteroids as markers or signals. Imagine an alien species wanting to communicate across the vast distances of space. Instead of beaming messages into the void, they could manipulate asteroids, altering their orbits or compositions in ways that stand out to anyone looking. These altered asteroids could serve as cosmic signposts, pointing the way to their creators. It's a fascinating idea, but one that raises an obvious question. Why haven't we found any evidence of this? The answer might lie in the sheer scale of the challenge. The asteroid belt contains millions of objects, and detecting subtle anomalies among them is like searching for a single grain of sand on a beach. Even with advanced telescopes and spacecraft, it's incredibly difficult to spot something that doesn't fit the natural patterns of these ancient rocks. Plus, if an alien civilization did use asteroids as signals, they might have done so millions or even billions of years ago. Any traces they left behind could have been erased by collisions, erosion, or the passage of time. Despite these challenges, the search continues. Scientists are using cutting-edge technology to study asteroids in unprecedented detail, looking for anything unusual, whether it's an unexpected composition, an odd orbit, or even a strange magnetic field. While no definitive evidence of alien activity has been found, the very act of searching pushes the boundaries of what we know and challenges us to think creatively about how life or intelligence might manifest in the universe. As we ponder the possibility of alien markers among the asteroids, another question arises. What if these ancient rocks could do more than just signal other civilizations? What if they could help us travel to them? This brings us to the next mystery, the potential for asteroid-based propulsion systems, a concept that could revolutionize space exploration and take us farther than ever before. What if the key to unlocking the stars lies not in building bigger rockets, but in using the asteroids themselves as cosmic fuel stations? This is the intriguing concept behind asteroid-based propulsion systems, a revolutionary idea that could transform the way we explore the universe. Instead of launching all the fuel we need from Earth, what if we could mine asteroids for water, metals, and other resources, turning them into pit stops for spacecraft venturing into deep space? Let's dive into this bold vision and explore how it might work, and why it's not as far-fetched as it sounds. The idea hinges on one crucial resource found on many asteroids: water. Water isn't just essential for life, it's also a powerful tool for space travel. When split into hydrogen and oxygen, water can be used as rocket fuel, providing the energy needed to propel spacecraft across vast distances. Asteroids like Bennu and Ryugu, which have been found to contain significant amounts of water ice, could serve as natural fuel depots, offering a renewable source of propellant for missions to Mars, the outer planets, and beyond. But water isn't the only resource asteroids could provide. Metals like iron, nickel, and platinum could be used to build and repair spacecraft, while rare earth elements could power advanced technologies. One ambitious concept, known as in situ resource utilization, envisions mining asteroids for these materials directly in space, reducing the need to launch everything from Earth. This approach could drastically lower the cost of space exploration and make long-term missions more sustainable. Of course, the challenges are immense. Mining asteroids in zero gravity, processing their materials, and safely storing volatile compounds like hydrogen would require groundbreaking technology and careful planning. Spacecraft would need to be equipped with advanced robotics and refueling systems, while mining operations would have to contend with the hazards of low gravity, radiation, and the unpredictable nature of asteroids themselves. Despite these hurdles, the potential rewards are staggering. Asteroid-based propulsion systems could open up the solar system to humanity in ways we've only dreamed of. Imagine a network of asteroid fuel depots, enabling spacecraft to travel farther and faster than ever before. Missions to the outer planets could become routine, and interstellar travel might move from the realm of science fiction to reality. As we dream of a future powered by asteroids, another question arises. What role did these ancient rocks play in the history of life on Earth? Could they have been the cosmic couriers that delivered the ingredients for life to our planet? That's the next mystery we'll explore. The story of life on Earth is deeply intertwined with the asteroids that roam our solar system. While we often think of these ancient rocks as distant, silent observers, the truth is far more dramatic. Asteroids have played a starring role in shaping the history of life on our planet. From delivering the building blocks of life to triggering catastrophic events that reshaped ecosystems, these cosmic wanderers have left an indelible mark on Earth's evolution. But how exactly did asteroids influence the rise and fall of life as we know it? Let's start with the most famous example, the Chicxulub impact. 66 million years ago, an asteroid roughly 10 kilometers wide slammed into what is now the Yucatan Peninsula in Mexico. The collision unleashed unimaginable destruction, sending shockwaves around the globe, igniting wildfires and blanketing the atmosphere with dust and debris. This single event is widely believed to have caused the extinction of the dinosaurs, clearing the way for mammals to rise and eventually dominate the planet. Without that asteroid, the world might look very different today, but the Chicxulub impact is just one chapter in a much longer story. Scientists believe that asteroid collisions have been a recurring theme throughout Earth's history, influencing the course of evolution in profound ways. Some researchers even suggest that earlier impacts may have delivered the water and organic molecules necessary for life to emerge. These cosmic couriers could have seeded Earth with the raw ingredients needed to kickstart the complex chemistry that led to living organisms. The mystery deepens when we consider how these impacts shaped ecosystems. Mass extinctions, while devastating, often create opportunities for new life forms to emerge and thrive. The aftermath of the Chicxulub impact, for example, saw the rise of mammals, which eventually gave rise to humans. In this way, asteroids might not just be agents of destruction, they could also be catalysts for change, driving the diversity and complexity of life on Earth. Yet, as much as we've learned, there's still so much we don't know. Why do some impacts cause mass extinctions, while others seem to have little effect? How do the materials asteroids carry influence the chemistry of our planet? And could future impacts, whether from asteroids or comets, once again alter the course of life on Earth? These questions remind us of the delicate balance that sustains life on our planet and the powerful forces that can disrupt it. As we reflect on the role asteroids have played in Earth's history, another intriguing possibility comes to mind. Could these ancient rocks also hold the key to humanity's future? Not just as a source of resources, but as a potential energy source that could power our civilization for generations to come. That's the next mystery we'll explore. The idea of harnessing energy from asteroids might sound like something from a futuristic sci-fi adventure, but it's a concept that's gaining serious traction among scientists and engineers. Imagine a future where asteroids aren't just mined for metals or water, they're transformed into cosmic power plants, generating energy to fuel humanity's journey across the stars. But how could we turn these ancient rocks into energy sources? And what would it take to make this vision a reality? One of the most promising ideas involves solar power. Many asteroids, especially those in the inner regions of the asteroid belt, are bathed in sunlight, making them ideal candidates for solar energy collection. Giant solar arrays could be deployed on their surfaces or in orbit around them, capturing the sun's rays and converting them into electricity. This energy could then be used to power mining operations, spacecraft, or even entire colonies, providing a sustainable and virtually limitless source of power. But solar power isn't the only possibility. Some asteroids contain radioactive materials like uranium and thorium, which could potentially be used in nuclear reactors. These reactors, either stationed on the asteroid itself or in nearby space stations, could generate immense amounts of energy, far surpassing what solar arrays could provide. The challenge, of course, is safely extracting and processing these materials in the harsh environment of space, where radiation and low gravity pose significant risks. The benefits of asteroid-based energy systems are hard to overstate. For one, they could drastically reduce the need to transport fuel and power sources from Earth, making space exploration more sustainable and cost-effective. They could also support long-term missions to distant destinations, like Mars or the outer planets, by providing a reliable energy source far from home. And in the long run, asteroid-based energy could even be sent back to Earth, helping to meet our planet's growing energy demands in a cleaner, more efficient way. However, the road to harnessing asteroid energy is fraught with challenges. Building and maintaining infrastructure in space requires cutting-edge technology, precise engineering, and a willingness to tackle the unknown. Solar arrays would need to withstand micrometeoroid impacts and extreme temperature swings, while nuclear systems would require robust safety measures to prevent radiation leaks. And let's not forget the logistical hurdles of transporting equipment to distant asteroids and ensuring it operates reliably over long periods. Despite these obstacles, the potential rewards are immense. Asteroid-based energy could revolutionize how we explore and utilize space, opening up new possibilities for humanity's future among the stars. As we continue to push the boundaries of what's possible, one thing is certain: the asteroids in our solar system hold untapped potential, waiting to be unlocked by the ingenuity and determination of future generations. But while we dream of asteroid-powered futures, there's another mystery about these ancient rocks that's equally fascinating: their strange and varied colors. Why do some asteroids appear red, while others look blue or even metallic? What secrets do these colors hold, and what can they tell us about the history of these cosmic wanderers? That's the next mystery we'll explore. If you've ever imagined asteroids as dull, gray rocks floating lifelessly through space, think again. These ancient bodies come in a stunning array of colors ranging from deep reds to icy blues, and each hue tells a story about the asteroid's composition, history, and even its journey through the solar system. But what causes these vibrant differences, and what secrets do they hold about the asteroid belt's past? Let's dive into the fascinating mystery of asteroid colors and uncover what they reveal about these cosmic wanderers. Take the asteroid Phaethon, for example. Unlike most of its rocky neighbors, Phaethon has a striking blue hue, a rarity among asteroids. Scientists believe this unique color is linked to its composition and history. Phaethon is thought to be the source of the Geminid meteor shower, and its blue color might result from intense heating as it swings close to the sun, causing its surface to bake and change. This process, known as thermal alteration, could be responsible for the asteroid's unusual appearance, making it a standout in the asteroid belt. But Phaethon is just one example. Other asteroids display a rainbow of colors, each one a clue to its origins. Reddish asteroids, for instance, are often rich in organic compounds and minerals like olivine, hinting at a history of water or other volatile substances. These colors can reveal how long an asteroid has been exposed to space radiation, or how much it's been bombarded by micrometeoroids over billions of years. On the other hand, metallic asteroids tend to appear gray or silver, reflecting their iron and nickel content, while some carbonaceous asteroids are so dark they're almost black, their surfaces coated in carbon-rich materials. The challenge for scientists is decoding these colors. By studying the light reflected off an asteroid's surface, researchers can analyze its spectrum, the unique fingerprint of its composition. This technique has led to some surprising discoveries. For example, some asteroids that appear red at first glance might actually be blue beneath a thin layer of dust. their true colors hidden by eons of space weathering. These color variations aren't just cosmetic, they're windows into the asteroid belt's complex history. They tell us about the conditions in the early solar system, the processes that shaped these rocks, and even how they've interacted with other objects over time. But as we decode these visual clues, another intriguing question arises. Could these colors be used for more than just scientific study? What if they played a role in communication, not just between humans, but between civilizations across the stars? This brings us to the next mystery, the potential for asteroid-based communication systems, a concept that could transform how we think about interstellar messaging. Imagine a future where messages from distant stars don't just fade into the void, but are picked up and amplified by asteroids acting as cosmic relay stations. This is the intriguing concept behind asteroid-based communication systems, a bold idea that could revolutionize how we send and receive signals across the vastness of space. But how would such a system work, and what challenges would we face in turning these ancient rocks into interstellar messengers? Let's explore this fascinating possibility and uncover how asteroids might become the backbone of a galactic communication network. The idea is as simple as it is ambitious. Asteroids, with their stable orbits and strategic locations, could serve as natural relay points for transmitting signals between Earth and distant spacecraft or even other civilizations. By equipping these rocks with advanced communication technology, think powerful transmitters and receivers, we could create a network that spans the solar system and beyond. This would allow us to maintain contact with missions to the outer planets, interstellar probes, and even potential extraterrestrial neighbors. One of the biggest challenges in space communication is the sheer distance signals must travel. As spacecraft venture farther from Earth, the strength of their signals weakens, making it harder to send and receive data. Asteroids, positioned at key points in the solar system, could act as signal boosters, amplifying and redirecting these transmissions to ensure they reach their destination. For example, an asteroid orbiting between Mars and Jupiter could serve as a relay station for missions to the outer planets, reducing the time and energy needed to send data back to Earth. But setting up such a system is no small feat. Asteroids are far from ideal platforms for delicate electronics. Their surfaces are often jagged and unstable, their environments harsh and unforgiving. Any equipment placed on an asteroid would need to withstand extreme temperatures, micrometeoroid impacts, and the constant barrage of solar radiation. Plus, the logistics of transporting and installing this technology in space would require breakthroughs in robotics and spacecraft design. Despite these hurdles, the potential benefits are enormous. An asteroid-based communication network could make deep space exploration more efficient and reliable, enabling real-time communication with missions that are currently out of reach. It could also open up new possibilities for interstellar messaging, allowing us to send signals to distant stars or listen for replies. In a way, asteroids could become the cosmic equivalent of cell towers, connecting humanity to the farthest reaches of the universe. As we ponder the possibilities of asteroid-based communication systems, another tantalizing mystery comes into focus. Could these ancient rocks also hold clues to one of the greatest unsolved questions in modern science, the nature of dark matter? That's the next mystery we'll explore. Dark matter is one of the most elusive mysteries in modern science. It makes up about 85% of the universe's mass, yet it doesn't emit, absorb, or reflect light, making it invisible to our telescopes. For decades, scientists have been searching for ways to detect this enigmatic substance, and while most efforts focus on deep space or underground experiments, there's a fascinating, if speculative, idea that asteroids might hold the key. Could these ancient rocks, drifting silently through the solar system, help us uncover the secrets of dark matter? The concept hinges on a unique property of asteroids: their isolation. Unlike planets, which are surrounded by atmospheres and magnetic fields, asteroids are bare, exposed to the cosmic environment. Some researchers suggest that if dark matter interacts with normal matter, even weakly, its effects might be detectable on asteroids. The idea is that dark matter particles could occasionally collide with the atoms in an asteroid's surface, leaving behind subtle traces, perhaps in the form of heat, vibrations, or even microscopic changes in the rock's structure. Of course, detecting these traces is no small feat. The signals would be incredibly faint, buried beneath the noise of other cosmic phenomena like solar radiation or micrometeoroid impacts. To make matters even more challenging, asteroids are constantly moving, rotating, and experiencing temperature changes, all of which could mask any potential dark matter interactions. Scientists would need to develop highly sensitive instruments capable of distinguishing these subtle effects from the asteroid's natural activity. Despite the challenges, the potential payoff is immense. If asteroids could be used to detect dark matter, it would open up a whole new avenue for research, complementing existing methods and potentially providing insights that other experiments can't. It's a long shot, but as history has shown, some of the greatest scientific breakthroughs have come from exploring unconventional ideas. As we ponder the possibility of using asteroids to unlock the secrets of dark matter, another intriguing question arises. Could these ancient rocks also serve as cosmic observatories, helping us peer deeper into the universe than ever before? This brings us to the next mystery: the potential for asteroid-based telescopes, a concept that could revolutionize how we explore the cosmos. What if the key to unlocking the deepest secrets of the universe wasn't on Earth, or even in orbit around our planet, but on an asteroid millions of miles away? This is the intriguing idea behind asteroid-based telescopes, a concept that could revolutionize how we observe the cosmos. Imagine a telescope perched on a distant asteroid, free from the interference of Earth's atmosphere, offering an unparalleled view of distant stars, galaxies, and perhaps even exoplanets. But what would it take to make this vision a reality? And why would asteroids make such ideal observatories? One of the biggest advantages of placing telescopes on asteroids is their isolation. Unlike Earth-based telescopes, which have to contend with light pollution, atmospheric distortion, and weather, asteroid-based instruments would operate in the pristine environment of space. This would allow them to capture images and data with incredible clarity, revealing details that are currently beyond our reach. For example, a telescope on an asteroid could study the atmospheres of distant exoplanets with unprecedented precision, searching for signs of water, oxygen, or even life. But building a telescope on an asteroid isn't as simple as just plopping one down and hitting record. Asteroids are far from stable platforms. Many are irregularly shaped, spin unpredictably, and lack the gravity needed to keep equipment firmly in place. To overcome these challenges, scientists would need to develop innovative stabilization techniques. One possibility is to anchor the telescope deep within the asteroid's surface, using its mass to provide a stable foundation. Another approach involves using gyroscopes and thrusters to counteract the asteroid's movement, ensuring the telescope remains steady and focused. the benefits of such a system could be game-changing. A telescope on an asteroid could observe the cosmos continuously, without the interruptions of day-night cycles or atmospheric interference. It could also be positioned in unique locations, such as the far side of an asteroid, shielding it from the sun's glare and providing a clear view of the darkest regions of space. And because asteroids are scattered throughout the solar system, they could serve as multiple vantage points, allowing us to triangulate observations and gather more detailed data. Of course, the challenges are immense. Transporting and assembling a telescope on an asteroid would require advanced robotics and precise engineering. The telescope would also need to withstand the harsh conditions of space, including extreme temperatures, micrometeoroid impacts, and radiation. But if we can overcome these hurdles, the rewards could be extraordinary. Asteroids could become the ultimate cosmic observatories, offering us a front-row seat to the universe's greatest mysteries. As we dream of peering deeper into the cosmos from the surface of an asteroid, another question arises. Could these ancient rocks also play a role in the search for habitable planets? What if asteroids aren't just tools for observing the universe, they're also stepping stones to finding new homes among the stars? That's the next mystery we'll explore. As we gaze at the stars, wondering if life exists beyond Earth, one of the most critical questions we face is this: how do we find a planet that could support life? Surprisingly, the answer might lie not in the distant stars themselves, but in the asteroids that orbit much closer to home. These ancient rocks, often overlooked as mere cosmic debris, could hold the key to identifying habitable worlds and even the conditions necessary for life to thrive. But how can asteroids, so small and barren, help us in this grand search? Asteroids are like cosmic time capsules, preserving the raw materials and conditions of the early solar system. By studying their composition, we can piece together the building blocks that were present when planets formed. For instance, carbonaceous asteroids, rich in water and organic molecules, suggest that these essential ingredients for life were widespread in the early solar system. If similar asteroids exist around other stars, they could indicate that those systems also have the necessary components for life. In this way, asteroids serve as proxies, helping us understand what to look for when searching for habitable planets in distant star systems. But it's not just about the ingredients. Asteroids can also reveal the processes that shape a planetary system. Collisions between asteroids, for example, can scatter water and organic materials across a system, potentially delivering them to young planets. If we find evidence of such processes in other systems like debris disks or asteroid belts, it could suggest that planets there have received the same life-giving resources that Earth once did. This connection between asteroids and habitability opens up a new way to assess whether a distant world might be a good candidate for life. The search for habitable planets also depends on understanding the stability of a system. Asteroids can provide clues here as well. A system with a well-organized asteroid belt, like our own, might indicate a stable environment where planets can form and evolve without constant bombardment. On the other hand, a chaotic belt with frequent collisions could suggest a more volatile system, where life might struggle to take hold. By studying the structure and behavior of asteroid belts in other systems, we can gauge the likelihood of finding stable, life-friendly planets. As we decode the secrets of asteroids to aid our search for habitable worlds, another fascinating possibility emerges. Could these ancient rocks also help us grow food in space? Imagine a future where asteroids become the foundation for sustainable agriculture, providing the resources needed to sustain life on long-term missions or even colonies. This brings us to our next mystery, the potential for asteroid-based agriculture, a concept that could revolutionize how we think about feeding humanity beyond Earth. Imagine a future where astronauts don't just survive on prepackaged meals, but grow fresh, vibrant crops in the shadow of an asteroid. Sounds like something out of a sci-fi movie, right? But the idea of asteroid-based agriculture is more than just a futuristic fantasy. It's a possibility that could revolutionize how we approach long-term space missions. Growing food on these ancient rocks could provide a sustainable way to support human life far from Earth, turning asteroids into cosmic gardens. But how exactly would that work? And what challenges would we face in turning barren space rocks into fertile farmland? The first hurdle is obvious. Asteroids lack the essential ingredients for life as we know it. They have no soil, no atmosphere, and no liquid water, at least not in a form that's easily accessible. To grow food, we'd need to create closed-loop ecosystems, where every resource is carefully recycled and reused. Think of it as a high-tech greenhouse, but one that operates in the harsh, airless environment of space. Plants would need to be grown hydroponically or aeroponically, their roots suspended in nutrient-rich water or mist instead of soil. Water could be extracted from asteroids themselves, using their ice deposits or chemically breaking down minerals to produce it. Light is another challenge. Most asteroids are far from the sun, meaning solar energy would be scarce. To compensate, we'd need to rely on artificial lighting, powered by solar arrays or even nuclear reactors. The systems would have to be incredibly efficient, minimizing waste and maximizing output to ensure a steady supply of food. And let's not forget the psychological benefits. Freshly grown food could provide a taste of home for astronauts, boosting morale during long missions. The potential benefits are enormous. Asteroid-based agriculture could reduce the need to transport food from Earth, making missions more sustainable and cost-effective. It could also serve as a stepping stone for colonies on Mars or beyond, providing a model for growing food in other harsh environments. But the challenges are just as significant. Creating self-sustaining ecosystems in space requires breakthroughs in biology, engineering, and resource management. Every aspect, from temperature control to waste recycling, would need to be meticulously planned and executed. As we dream of turning asteroids into cosmic farms, another intriguing question emerges. What if these ancient rocks aren't just silent, barren worlds? What if they're making sounds, faint, eerie noises that hold secrets about their composition and history? That's the next mystery we'll explore. When you think of the asteroid belt, you probably imagine a silent, desolate expanse of space, a place where sound doesn't exist. But what if we told you that some asteroids are far from silent? In fact, they're making noises. These faint, eerie sounds, often too subtle for the human ear to detect, have puzzled scientists and opened up a whole new way of studying these ancient rocks. So, what's causing these cosmic whispers, and what can they tell us about what's happening deep inside these mysterious bodies? The phenomenon of asteroid sounds was first discovered during missions like Hayabusa 2 and OSIRIS-REx, which used sensitive instruments to listen to these distant objects. What they found was astonishing. Some asteroids emit low-frequency vibrations, almost like a hum or a rumble. These sounds are thought to be caused by tiny movements within the asteroid itself, shifts in its structure, the settling of its surface, or even the release of trapped gases. Imagine a giant, rocky sponge slowly creaking and groaning as it adjusts to the forces acting upon it. But these sounds aren't just random noise. They're like a form of cosmic sonar, revealing details about the asteroid's internal makeup. By analyzing the frequency and intensity of these vibrations, scientists can infer whether an asteroid is solid or a loose rubble pile, whether it contains water ice or volatile compounds, and even how it might respond to external forces like impacts or gravitational tugs. In a way, listening to asteroids is like performing an ultrasound on a patient, using sound waves to map what lies beneath the surface. The implications of this discovery are profound. For one, it could help us better understand how asteroids behave, which is crucial for predicting their movements and planning missions to study or even mine them. It could also provide clues about their origins. For example, if an asteroid's sounds suggest it's a rubble pile, it might have formed from the debris of a larger body that was shattered in a collision. On the other hand, a solid, monolithic asteroid might have a very different history, one that's preserved in its internal structure. As we decode these cosmic sounds, another intriguing possibility emerges. Could we one day use asteroids not just for science or resources, but for art and culture? What if these ancient rocks became canvases for human creativity, inspiring new forms of expression that transcend the boundaries of Earth? That's the next mystery we'll explore. What if the vast, silent expanse of the asteroid belt could become a stage for human creativity? Imagine transforming these ancient, barren rocks into cosmic canvases, where art and culture transcend the boundaries of Earth. This is the intriguing concept behind asteroid-based art and culture, a bold idea that challenges us to think beyond our planet and reimagine how we express ourselves. But what would it take to create art in the void of space? And what could this mean for humanity's relationship with the cosmos? Creating art on an asteroid is no simple feat. The challenges are immense, starting with the environment itself. Asteroids lack the atmosphere, gravity, and stable surfaces we take for granted on Earth. Artists would need to adapt to zero gravity, extreme temperatures, and the constant threat of micrometeoroid impacts. Traditional tools like brushes or chisels would be useless. Instead, artists might rely on lasers, robotic arms, or even spacecraft to etch or paint their designs onto the asteroid's surface. The result could be a fusion of technology and creativity, where the process of making art becomes as groundbreaking as the art itself. But why go to such lengths? The benefits of asteroid-based art extend far beyond the aesthetic. For one, it could serve as a powerful symbol of humanity's ability to adapt and thrive in the harshest environments. A sculpture or mural on an asteroid would be a testament to our ingenuity, a beacon of creativity shining in the darkness of space. It could also inspire new forms of cultural expression, blending the traditions of Earth with the limitless possibilities of the cosmos. Imagine a painting that uses the asteroid's natural colors and textures as part of its design, or a sound installation that incorporates the faint vibrations of the rock itself. The possibilities are as vast as space itself. This idea also raises profound questions about the purpose of art. Could asteroid-based creations help us connect with other civilizations? If an alien species ever visited our solar system, they might find these works and see them as a message, a declaration of humanity's presence and creativity. In this way, art on asteroids could become a form of interstellar communication, transcending language and culture to convey something universal about who we are. As we dream of turning asteroids into cosmic galleries, another question arises. Could these ancient rocks also hold clues to the existence of parallel universes? What if the mysteries of the asteroid belt extend beyond our own reality, offering glimpses into other dimensions? This brings us to the next mystery, the role of asteroids in the search for alternate realities. The idea of parallel universes has long been a staple of science fiction, but what if it's not just a fantasy? What if the key to detecting alternate realities lies hidden among the asteroids in our solar system? This might sound like the plot of a blockbuster movie, but some scientists believe that asteroids could play a role in the search for evidence of parallel universes. It's a concept that pushes the boundaries of our understanding, blending the mysteries of quantum physics with the ancient rocks drifting silently through space. So, how could asteroids help us uncover the existence of other dimensions? At the heart of this idea is the notion that parallel universes, if they exist, might leave subtle imprints on our own reality. One theory suggests that interactions between particles in our universe and those in a parallel one could produce faint, detectable anomalies, tiny ripples in the fabric of space-time. These anomalies might be too small to notice on Earth, but the isolation of asteroids makes them ideal candidates for such detection. Far from the noise and interference of planets, asteroids could act as cosmic sensors, picking up signals that hint at the presence of alternate realities. But how would this work in practice? Imagine an asteroid drifting through space, its surface dotted with ultra-sensitive instruments designed to detect the slightest disturbances. If a parallel universe were to brush against our own, even briefly, it might leave behind a faint signature, perhaps a sudden spike in radiation, a strange gravitational pull, or an unexplained vibration in the asteroid's structure. These anomalies, while subtle, could be the first clues that we're not alone in the multiverse. Of course, the challenges are immense. Detecting such faint signals requires technology far beyond what we currently possess. Instruments would need to be incredibly precise, capable of distinguishing between natural phenomena and potential evidence of parallel universes. And even if we did detect something unusual, proving its evidence of another dimension would be an entirely different hurdle. The scientific community would demand rigorous proof, and the very nature of these anomalies makes them difficult to study and replicate. Despite the obstacles, the idea is tantalizing. Asteroids, with their ancient, untouched surfaces, could be the perfect cosmic laboratories for exploring one of the greatest mysteries in physics. They remind us that the universe is far stranger and more complex than we can imagine, and that even the most speculative ideas might hold a kernel of truth. As we ponder the possibility of asteroids revealing the existence of parallel universes, another mind-bending question arises. Could these ancient rocks also hold the key to time travel? What if asteroids, with their unique properties and long histories, could help us unlock the secrets of moving through time? That's the next mystery we'll explore. The idea of time travel has captivated humanity for centuries, fueling countless stories, theories, and dreams. But what if the key to unlocking this elusive concept lies not in the pages of science fiction or the depths of theoretical physics, but among the ancient rocks of the asteroid belt? This is the bold and fascinating mystery we're diving into next. Could asteroids serve as portals or markers for time travel? At first glance, the idea seems far-fetched, but when we delve into the science, it's not entirely out of the question. One theory suggests that asteroids, with their dense, compact structures and unique gravitational fields, could act as natural time capsules. not just preserving the past, but potentially bending the very fabric of time itself. Imagine an asteroid with an incredibly strong gravitational pull, a phenomenon that could theoretically warp space-time enough to create a time dilation effect. In this scenario, time might pass more slowly near the asteroid compared to the rest of the universe, creating a kind of temporal distortion. But how could we harness this? Some researchers speculate that asteroids rich in heavy elements, like platinum or iridium, might possess the gravitational conditions needed to create these distortions. By studying their composition and gravitational influence, we might uncover clues about how to manipulate time itself. Of course, this is speculative. No one's suggesting we'll be hopping onto an asteroid and popping into the future anytime soon. But the idea opens up intriguing possibilities for how we understand the relationship between gravity, space, and time. The challenges of proving such theories are immense. Time travel, if it's even possible, would require conditions far beyond our current technological capabilities. We'd need to find an asteroid with the precise mass, density, and gravitational properties to create a significant time dilation effect. Even then, the practical applications, let alone the ethics, of time travel are fraught with complexity. What would it mean for humanity to control time? How would it reshape our understanding of cause and effect, free will, and destiny? Despite these hurdles, the concept of asteroid-based time travel pushes the boundaries of our imagination and challenges us to think bigger. It forces us to confront the limits of our knowledge and consider the possibility that the universe holds secrets we've yet to uncover. And as we ponder these cosmic mysteries, another question emerges. Could asteroids also play a role in the search for wormholes, those hypothetical shortcuts through space-time that could connect distant parts of the universe? That's the next mystery we'll explore, and it's one that could change how we think about the very nature of reality. What if the key to unlocking the universe's greatest shortcuts, wormholes, lies hidden among the asteroids drifting silently through our solar system? This might sound like the plot of an epic space opera, but the idea of asteroids being linked to wormholes is a mystery that's captivated scientists and dreamers alike. Could these ancient rocks, often dismissed as mere remnants of planetary formation, actually be gateways to distant parts of the cosmos? Let's delve into this tantalizing possibility and explore whether asteroids could hold the secrets to traversing space-time itself. Wormholes, theoretical tunnels through space-time, are one of the most fascinating concepts in modern physics. They're often described as cosmic shortcuts, allowing travel between distant points in the universe, or even between universes in an instant. While wormholes remain purely hypothetical, some scientists believe that if they exist, they might be linked to massive, dense objects like black holes or neutron stars. But here's where asteroids come in. Could these smaller, less massive objects also play a role? One intriguing theory suggests that asteroids with unusual gravitational or magnetic properties might act as markers for wormholes. Imagine an asteroid with a strange, unexplained gravitational anomaly, something that doesn't align with its size or composition. Could this anomaly be a clue, a subtle signpost pointing toward a nearby wormhole? Alternatively, some researchers speculate that asteroids could serve as stabilizers for wormholes, their gravitational fields helping to keep these hypothetical tunnels open and functional. Of course, detecting such connections is no easy task. Wormholes, if they exist, would likely be incredibly small and unstable, making them nearly impossible to observe directly. Even indirect evidence, like gravitational anomalies or unusual energy signatures, would require highly sensitive instruments and a lot of patience to detect. And let's not forget the sheer scale of the challenge. The asteroid belt alone contains millions of objects, each one a potential candidate for investigation. Despite the hurdles, the idea is undeniably captivating. If asteroids could be linked to wormholes, it would revolutionize our understanding of the universe and open up possibilities for exploration that we can barely imagine. It would also remind us of how much we still have to learn about the cosmos, and how the smallest, seemingly insignificant objects might hold the keys to the greatest mysteries. As we ponder the cosmic potential of asteroids, another intriguing question arises. What if these ancient rocks could do more than just connect us to distant stars? What if they could inspire us in ways we've never considered through music? This brings us to the next mystery, the possibility of asteroid-based music, a concept that blends science, art, and the boundless creativity of the human spirit. Imagine a symphony composed not by human hands, but by the movements and vibrations of ancient asteroids drifting through the void of space. This is the intriguing concept behind asteroid-based music, a fusion of science and art that transforms the silent, lifeless rocks of the asteroid belt into melodic masterpieces. But how do you turn raw data from these cosmic wanderers into music? And what can this unique blend of disciplines teach us about both the universe and ourselves? Let's dive into this harmonious mystery and uncover how asteroids are inspiring a new frontier in creativity. The idea of translating scientific data into music isn't entirely new. For decades, researchers have used sonification, the process of converting data into sound, to analyze complex information in fields ranging from astronomy to medicine. When it comes to asteroids, this process involves taking measurements like their rotation rates, surface vibrations, or even the chemical signatures of their materials and mapping them to musical notes, rhythms, and textures. The result is a haunting, otherworldly soundscape that offers a fresh perspective on these ancient rocks. Take, for example, the asteroid Bennu, which was studied extensively by NASA OSIRIS-REx mission. Scientists used data from the spacecraft to create a musical representation of Bennu's surface, transforming its topography into a series of tones and rhythms. The result was a piece of music that captured the asteroid's rugged, chaotic terrain in a way that visual images simply couldn't. It's a fascinating example of how science and art can come together to create something entirely new, offering insights that resonate on both an intellectual and emotional level. But creating asteroid-based music isn't without its challenges. One of the biggest hurdles is deciding how to interpret the data. Should the pitch of a note correspond to an asteroid's temperature or its distance from the Sun? Should its rotation speed dictate the tempo or the intensity of its gravitational pull? These decisions can dramatically alter the final composition, raising questions about objectivity versus creativity in the process. It's a delicate balance, one that requires both scientific rigor and artistic intuition. The benefits of this unique approach are as diverse as the asteroids themselves. For scientists, sonification offers a new way to analyze and understand data, revealing patterns and anomalies that might otherwise go unnoticed. For artists, it's an opportunity to explore uncharted creative territory, drawing inspiration from the cosmos itself. And for the rest of us, asteroid-based music provides a bridge between the abstract world of science and the deeply personal experience of art, making the mysteries of the universe more accessible and relatable. As we marvel at the possibilities of asteroid-based music, another intriguing question emerges. Could these ancient rocks also hold clues to the strange and enigmatic world of quantum phenomena? What if the asteroid belt is more than just a collection of rocks? It's a cosmic laboratory for exploring the fundamental nature of reality. That's the next mystery we'll explore, and it's one that could change how we think about everything from particles to the fabric of space-time itself. Now, let's venture into one of the most speculative and mind-bending mysteries of the asteroid belt. Could these ancient rocks help us uncover the secrets of quantum phenomena? Quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, is already strange enough on Earth. But what if asteroids, with their unique environments and isolation, could serve as cosmic laboratories for studying quantum effects in ways we've never imagined? The idea hinges on the fact that asteroids exist in a nearly perfect vacuum, far from the noise and interference of Earth's atmosphere. This makes them ideal for observing subtle quantum phenomena that might be drowned out in terrestrial experiments. For instance, some theories suggest that asteroids could be used to detect quantum entanglement, a phenomenon where particles remain connected across vast distances, instantaneously influencing each other's states. By placing detectors on asteroids, we might be able to observe these connections over unprecedented scales, potentially revealing new insights into how quantum mechanics operates in the cosmos. Another intriguing possibility involves quantum tunneling, a process where particles seemingly teleport through barriers that should be impossible to cross. Asteroids, with their dense, compact structures, could provide the perfect environment to study this phenomenon. Imagine setting up an experiment on an asteroid's surface, using its natural materials to create barriers and observe how particles behave. The results could help us understand not just quantum tunneling, but also how quantum effects might influence larger-scale processes, like the formation of planets or even the evolution of the universe itself. Of course, the challenges are immense. Detecting quantum effects on asteroids would require incredibly precise instruments, capable of functioning in the harsh conditions of space. The isolation of asteroids also means that any data collected would need to be transmitted back to Earth, adding another layer of complexity. And then there's the question of funding and resources. Building and launching such experiments would be a monumental task, requiring international collaboration and cutting-edge technology. Despite these hurdles, the potential rewards are extraordinary. If asteroids could help us unlock the mysteries of quantum mechanics, it would open up entirely new avenues of research, from quantum computing to our understanding of the fundamental nature of reality. These ancient rocks, often seen as relics of the past, might just hold the keys to the future of science. As we ponder the quantum mysteries of the asteroid belt, another fascinating possibility comes to mind. What if these ancient rocks could also serve as canvases for storytelling? Could asteroids inspire narratives that transcend time and space, weaving together the threads of science, history, and imagination? That's the next mystery we'll explore. What if the silent, drifting asteroids of our solar system could become the stage for humanity's greatest stories? This is the intriguing concept behind asteroid-based storytelling, a creative frontier where the cold, barren rocks of the asteroid belt are transformed into settings for epic tales of adventure, mystery, and discovery. But how do you craft a compelling narrative in an environment so alien and unforgiving? Let's explore how these ancient cosmic wanderers could inspire stories that push the boundaries of human imagination. Creating stories set on asteroids presents unique challenges and opportunities. Unlike Earth, with its lush landscapes and familiar environments, asteroids are harsh, airless, and often irregularly shaped. The lack of gravity, extreme temperatures, and constant threat of micrometeoroid impacts create a setting that demands creativity and ingenuity from storytellers. How do you breathe life into a world where survival depends on technology and sheer human willpower? How do you make a landscape of jagged rocks and endless void feel as vivid and immersive as the forests, oceans, and cities of Earth? One approach is to lean into the alien nature of asteroids, using their strangeness to create tension and wonder. Imagine a story where a lone astronaut, stranded on a spinning asteroid, must navigate its treacherous terrain while racing against time to repair a damaged spacecraft. Or picture a colony on an asteroid, struggling to survive in a fragile, self-sustaining habitat, only to discover that their new home holds a secret buried deep beneath its surface. The isolation and danger of these environments can serve as powerful storytelling tools, amplifying the stakes and highlighting the resilience of the human spirit. But asteroid-based storytelling isn't just about the challenges, it's also about the possibilities. These ancient rocks, with their rich histories and hidden mysteries, offer endless inspiration. A single asteroid could become the backdrop for a tale of interstellar exploration, a cosmic mystery, or even a philosophical meditation on humanity's place in the universe. The very act of imagining life on an asteroid forces us to think beyond the familiar, to explore new ways of living, thinking, and connecting with the cosmos. The benefits of this kind of storytelling extend far beyond entertainment. By envisioning life on asteroids, we can inspire new ideas for space exploration and colonization. Stories have the power to spark curiosity, drive innovation, and even shape the future. They remind us that the universe is not just a place to study, it's a place to dream. As we explore the creative potential of asteroids, another profound question emerges. Could these ancient rocks also hold the key to understanding something even more mysterious, the nature of cosmic consciousness? What if the asteroid belt is more than just a collection of rocks? It's a gateway to exploring the deepest mysteries of the mind and the universe. That's the next mystery we'll explore, and it's one that could change how we think about life, intelligence, and the cosmos itself. What if the asteroids drifting silently through our solar system are more than just ancient rocks? What if they are fragments of a cosmic mind? This might sound like something from the pages of a science fiction novel, but the idea of a universal consciousness, or a shared awareness that permeates the universe, is a concept that has fascinated philosophers, scientists, and dreamers for centuries. Could asteroids, with their ancient origins and mysterious compositions, hold clues to this profound enigma? Let's explore this speculative yet captivating mystery and see how these cosmic wanderers might connect us to something far greater than ourselves. The concept of cosmic consciousness is rooted in the idea that the universe itself might possess a form of awareness, a subtle, interconnected web of thought or energy that binds all things together. Some theories suggest that this consciousness could be encoded in the very fabric of space-time, or perhaps in the fundamental particles that make up matter. If that's true, then asteroids, as some of the oldest and most unchanged objects in the solar system, could serve as natural repositories for this universal awareness. Their untouched surfaces and ancient compositions might preserve subtle traces of this cosmic mind, waiting to be uncovered. But how could we detect such a thing? One speculative approach involves studying the way asteroids interact with their environment. For instance, the faint vibrations or electromagnetic signals emitted by certain asteroids might carry patterns or frequencies that hint at a deeper, underlying order. If these patterns were found to align with theories about universal consciousness, it could suggest that asteroids are more than just passive observers of the cosmos. They might be active participants in a grand, interconnected system. Of course, the challenges of proving this idea are immense. Consciousness, even on Earth, is a poorly understood phenomenon, let alone the idea of a universal version of it. Detecting subtle signals from asteroids would require technology far beyond what we currently possess, not to mention a paradigm shift in how we think about the nature of reality itself. Yet, the very act of exploring this possibility pushes the boundaries of our understanding, forcing us to consider questions that go beyond the physical and into the realm of the metaphysical. As we ponder the mysteries of cosmic consciousness, another intriguing question arises. Could asteroids also inspire a new way of thinking about our place in the universe? This brings us to the next mystery, the potential for asteroid-based philosophy, a concept that challenges us to reimagine our relationship with the cosmos. Asteroids, those ancient, silent wanderers of the solar system, have long been subjects of scientific fascination. But what if we shifted our gaze from their physical properties to something more abstract, their philosophical potential? This brings us to the 33rd mystery, asteroid-based philosophy. Could these celestial bodies, so often seen as lifeless and inert, serve as metaphors for deeper questions about existence, purpose, and our place in the universe? Philosophy has always drawn inspiration from the natural world, from the ancient Greeks who pondered the stars to modern thinkers who grapple with the implications of space exploration. Asteroids, with their timeless existence and enigmatic origins, offer a unique lens through which to explore profound ideas. For instance, their formation from the debris of a chaotic early solar system can symbolize the idea of order emerging from chaos, a theme that resonates across cultures and disciplines. What does it mean for humanity, a species born from the same cosmic turmoil, to now seek meaning and structure in the universe? But applying philosophy to asteroids isn't without its challenges. These objects are so alien to our everyday experience that connecting them to human questions can feel abstract, even forced. How do we relate to something that exists in a vacuum, devoid of life or atmosphere? Yet, this very challenge is what makes asteroid-based philosophy so compelling. It forces us to think beyond the familiar, to stretch our imaginations, and consider perspectives that are truly cosmic in scale. The benefits of this approach are profound. By using asteroids as philosophical subjects, we can explore themes like impermanence, resilience, and interconnectedness in new ways. An asteroid's journey through space, shaped by forces beyond its control, can serve as a metaphor for the human condition, a reminder that we, too, are shaped by forces larger than ourselves. At the same time, the asteroid's enduring presence over billions of years challenges us to think about time and legacy in ways that transcend our fleeting human lifespans. Asteroid-based philosophy also invites us to reconsider our relationship with the cosmos. These ancient rocks, often dismissed as mere debris, remind us that even the smallest, seemingly insignificant objects can hold profound meaning. They challenge us to see the universe not as a collection of separate entities, but as an interconnected whole, a perspective that aligns with many philosophical traditions, from Stoicism to Zen Buddhism. As we contemplate the philosophical implications of asteroids, another intriguing question arises. Could these ancient rocks also hold the key to understanding cosmic harmony? What if the asteroid belt, often seen as a chaotic jumble of rocks, is actually part of a larger, more intricate balance? That's the next mystery we'll explore, one that could reshape how we think about the universe and our place within it. What if the asteroid belt, often seen as a chaotic jumble of rocks, is actually part of a grand cosmic symphony? This brings us to the 34th mystery, the search for cosmic harmony through asteroids. At first glance, the asteroid belt might seem like a random scattering of debris, but what if there's an underlying order to its chaos? Could these ancient rocks, drifting silently through space, hold the key to understanding the delicate balance that governs the universe? The idea of cosmic harmony isn't new. For centuries, thinkers have pondered the idea of a universal order, a kind of natural rhythm that connects everything from the smallest particles to the vastest galaxies. Asteroids, with their ancient origins and complex interactions, offer a unique way to explore this concept. Their orbits, shaped by the gravitational pull of the Sun and planets, follow precise mathematical patterns, hinting at an underlying order that keeps the solar system in balance. But how could asteroids help us understand this harmony? One possibility lies in their composition. Each asteroid is a unique blend of materials, from metals and silicates to water, ice, and organic compounds. These variations aren't random, they are the result of processes that shaped the early solar system, processes that might reflect broader patterns of cosmic balance. By studying these materials, we can piece together how the universe organizes itself, from the smallest grains of dust to the largest celestial bodies. Another angle involves the asteroid belt's role in the solar system. Far from being mere debris, asteroids act as a kind of cosmic buffer, absorbing impacts that might otherwise disrupt the orbits of planets. This protective function suggests a deeper interconnectedness, a system where every object, no matter how small, plays a part in maintaining stability. It's a reminder that harmony isn't just about stillness, it's about dynamic balance, where forces like gravity, collisions, and time work together to create order from chaos. Proving this idea, however, is no simple task. The asteroid belt is vast and complex, with millions of objects interacting in ways we're only beginning to understand. Detecting patterns or connections requires advanced technology, from high-powered telescopes to computer simulations capable of modeling the belt's intricate dynamics. Even then, the results might be open to interpretation, leaving room for debate about whether what we're seeing is true harmony or simply the illusion of order. Yet the search itself is worthwhile. Whether or not we find definitive proof of cosmic harmony, exploring the idea challenges us to think bigger, to see the universe not as a collection of separate parts, but as a unified whole. And as we delve into this mystery, another intriguing possibility emerges. Could asteroids also inspire a sense of spirituality, connecting us to something greater than ourselves? That brings us to the next mystery, the potential for asteroid-based spirituality, a concept that blends science, philosophy, and the profound questions of existence. What if the silent, ancient rocks of the asteroid belt could become more than just subjects of scientific study? What if they could inspire a new kind of spiritual connection? This is the intriguing premise behind asteroid-based spirituality, a concept that merges the mysteries of the cosmos with the deepest questions of human existence. Could these distant, seemingly lifeless objects serve as symbols or even sacred sites for spiritual practices? And what might this mean for our understanding of ourselves and our place in the universe? At its core, asteroid-based spirituality challenges us to think beyond the boundaries of Earth. For millennia, humans have looked to the stars, mountains, and oceans as sources of wonder and reverence. But asteroids, with their timeless journeys through the void, offer something unique, a connection to the raw, unfiltered essence of the cosmos. Their ancient origins, dating back to the birth of the solar system, make them powerful symbols of continuity and change, reminding us that we, too, are part of a vast, interconnected tapestry. The idea of using asteroids as spiritual symbols isn't just poetic, it's deeply practical. In a world increasingly dominated by technology and noise, these distant rocks offer a kind of cosmic quiet, a space for reflection and connection. Imagine meditating on the idea of an asteroid, its silent journey through the void serving as a metaphor for the human experience, solitary, yet part of something much larger. Or consider the possibility of rituals or ceremonies inspired by asteroid orbits, their predictable yet awe-inspiring paths offering a sense of order amidst life's chaos. Of course, connecting with asteroids on a spiritual level comes with its own set of challenges. Unlike mountains or rivers, which we can see, touch, and even climb, asteroids are distant and inaccessible. Their stories are told not through direct experience, but through science and imagination. This distance, however, might also be their greatest strength. By forcing us to engage with something beyond our immediate reach, asteroids invite us to expand our sense of connection, to find meaning in the intangible and the infinite. The potential benefits of asteroid-based spirituality are profound. At a time when many feel disconnected from the natural world, these cosmic wanderers offer a new way to cultivate awe and wonder. They remind us that spirituality doesn't have to be confined to Earth. It can extend to the farthest reaches of the universe, embracing the mysteries of space as part of our shared human experience. As we reflect on the spiritual potential of asteroids, another intriguing question emerges. What if these ancient rocks could tie together all the mysteries we've explored in this video? What if they hold the key to understanding not just the cosmos, but ourselves? That brings us to the final, overarching mystery, the role of asteroids in connecting the dots between science, spirituality, and the human journey. Stay with us as we explore this final enigma, one that weaves together the threads of exploration, discovery, and meaning, offering a glimpse into how the asteroid belt might hold the answers to some of our deepest questions. As we've journeyed through the asteroid belt, exploring its countless mysteries, one question lingers: could all these enigmas, from the scientific to the speculative, be interconnected? This brings us to our 36th mystery, the grand unified theory of asteroids. Is there a deeper thread that ties together the origins of these ancient rocks, their bizarre shapes, their potential as cosmic resources, and even their role in spirituality and consciousness? Could these seemingly unrelated mysteries point to a unified understanding of asteroids, one that bridges the gap between science and imagination? At their core, asteroids are time capsules, preserving the raw materials and conditions of the early solar system. Their compositions, ranging from carbon-rich organics to metallic cores, tell the story of how planets formed and how life might have begun. Their irregular shapes and unpredictable orbits reveal the chaotic forces that shaped our cosmic neighborhood, while their potential as sources of water and precious metals hints at a future where asteroids could fuel humanity's expansion into space. But beyond these scientific insights lies something even more profound. Asteroids challenge us to think bigger, to see them not just as rocks, but as symbols of humanity's curiosity and resilience. The speculative mysteries, alien artifacts, cosmic consciousness, even the possibility of time travel, push this idea even further. They remind us that asteroids are more than just objects to study, they're canvases for our imagination. Whether we're dreaming of mining them for resources, using them as cosmic observatories, or finding spiritual meaning in their silent journeys, asteroids invite us to explore not just the universe, but ourselves. Yet for all we've learned, the asteroid belt remains a place of endless mystery. Every discovery raises new questions, and every mission brings us closer to understanding while also revealing how much we still don't know. This is the beauty of science. It's a never-ending journey, one that thrives on curiosity and collaboration. The grand unified theory of asteroids isn't about having all the answers, it's about embracing the questions. It's about recognizing that these ancient rocks, so often dismissed as mere debris, hold the keys to understanding our past, shaping our future, and connecting us to something greater than ourselves. As we continue to explore the asteroid belt, we're not just uncovering the secrets of the cosmos, we're uncovering the potential of humanity. With that in mind, let's turn to the final chapter of our journey, where we'll reflect on what all these mysteries mean for us and for the future of exploration. What awaits us as we venture deeper into the asteroid belt, and what role will these ancient rocks play in the story of humanity? That's where we're headed next. As we reach the end of our journey through the asteroid belt's 35 greatest mysteries, it's worth taking a moment to reflect on what we've uncovered. From the origins of these ancient rocks to their bizarre shapes, their potential as cosmic treasure chests, and even their speculative roles in time, travel, and consciousness, the asteroid belt is far more than a scattering of debris. It's a frontier of discovery. Each mystery we've explored, whether grounded in science or stretching into the realm of imagination, reveals just how much we still have to learn about our solar system and ourselves. These enigmas aren't just academic curiosities, they're windows into the past, present, and future of humanity's relationship with the cosmos. The asteroid belt holds clues to how planets formed, how life might have begun, and how we might one day thrive beyond Earth. But it also challenges us to think bigger, to consider questions that go beyond the physical and into the philosophical. What does it mean to explore? How do we find meaning in the vastness of space? And what role do we play in the grand tapestry of the universe? The importance of the asteroid belt as a scientific frontier cannot be overstated. Every mission to these ancient rocks, every sample collected, every image captured brings us closer to answering questions that have puzzled humanity for centuries. But it's not just about the science. The asteroid belt is also a place of wonder, a reminder that the universe is full of surprises waiting to be uncovered. It invites us to stay curious, to keep asking questions, and to never stop exploring. As we look to the future, the asteroid belt will undoubtedly play a central role in humanity's journey into space. Whether we're mining asteroids for resources, studying their compositions to understand the origins of life, or dreaming of the philosophical and spiritual connections they might inspire, these ancient rocks are a testament to the boundless potential of exploration. They remind us that the universe is not just a place to study, it's a place to dream. So, what's next? The mysteries of the asteroid belt are far from solved, and every answer we find only leads to more questions. That's the beauty of science and exploration. It's a never-ending journey, one that thrives on curiosity, collaboration, and the courage to venture into the unknown. As we close this chapter, I want to thank you for joining me on this journey through the asteroid belt. If you've enjoyed this video, don't forget to subscribe and hit the notification bell so you never miss an update. I'd also love to hear your thoughts in the comments below. What mystery fascinates you the most? What do you think we'll discover next? The cosmos is full of wonders waiting to be uncovered, and the asteroid belt is just the beginning. Stay curious, keep exploring, and remember, the universe is vast, but so is our capacity to understand it. Until next time, let's keep reaching for the stars.